Hello, everyone, and welcome to Beyond Bandwidth, Leviton's podcast series where we dive into network technology's hottest topics. I am your host from Leviton Network Solutions, Roy Chamberlain. This conversation has today's host, Todd Harpel, Senior Director of Copper Systems at Leviton Network Solutions, talking with Diane Forbes, CEO and Principal Consultant at NIS Consulting out of the Pacific Northwest. Diane and Todd are both contributors to the TIA. This episode moves the focus to the industry trends from a standards perspective on the apparent need for extended distance over copper, reviewing the case from multiple angles of the topic.
Well, thanks for being here, everyone. With me today is Diane Forbes with NIS, and I wanted to also mention that she is a colleague of mine with TIA, working on the TIA working groups together. So she's been a longtime member of that. Today, we're talking about extended distance trend that we're seeing in our industry for copper cabling going beyond 100 meters. And I wanted to just get Diane to introduce herself as well. So Diane, can you tell us a little bit about yourself?
Well, sure. I am in the Pacific Northwest, so we have beautiful landscape, but we also do a lot of work in our company with K-12 education in general, a lot of public projects. So we're constantly fighting this balance of value and cost and long-term needs. Our company has been around since the 80s, and we've seen a lot of shifting needs and requirements, technology available since that time. And I've had the pleasure of being here for the last decade or so. And we've got a great team here that works through challenges and problems with our clients around this connectivity issue.
Great. Thank you for being with us. And let's just jump right into it. As you know, and I know, this extended distance copper cabling channels going beyond 100 meters is really hot in the industry right now.
It is.
Have you been asked about this by your clients?
So we aren't asked specifically, can you go extended distance, right? But usually what happens is there will be an area or a location that a client wants to cover, and we tell them that it's really longer than the distance that they should be trying to go with a particular solution. And at that point, it usually becomes a question of, well, how do we do that? And evaluating the things. And often it's, cost versus benefit analysis for the client at that point. So they're asking more in a roundabout way than they are specifically to go outside of a standard approach.
That's actually my next question.
Mm-hmm.
Have you ever been asked by a client to design a whole cabling system that uses a maximum channel length that is longer than the 100 meters that's specified by TIA as the basis to design?
No. And again, not in that way, right? We have clients that say we absolutely do not want to go over, which is fantastic. We have other clients that say we have this space available. Perhaps there's not a space for a new cabinet or a frame room or something like that, but they will still want to put a device out where they are beyond their length limits. So no, they don't want us to design to it, but often they're willing to try it or accept it if they have a need.
Are there specific distances that you've encountered beyond 100 meters that you've been asked to include in your design? And what would be the longest distance you've been asked to include?
Yeah, I went looking at this a little bit because anecdotally I was like, oh gosh, I know we have a couple of these, but I really wasn't sure about the specific distances when I was thinking about this in preparation for our discussion today. And it looks like right around 450 feet is kind of the longest. Every once in a while we'll have something longer. Most recently it was just shy of 450 feet, which is 135-ish meters. And so that is fairly common, right? It's just outside. They don't really want to build a new space to support it. It's less around the ask of that distance, right? And it's more around, we've got this location at the corner of a building or the corner of a field, and we really need to cover it. How do we do that? Can we use this? Can we just try it and see what happens? Is usually the conversation.
Yeah, it's funny when we attend some of the Big C shows the last couple of years, We've had actually some contractors come up to us and say, hey, I was doing this project and the pathway to get to a certain location was just beyond 100 meters. And, we installed your such and such cable and yeah, it worked. And we go, well, that's good. It's not something that's included in our warranty,
Right,
but
right.
no, necessarily. But it's not an uncommon, but to your point, the distances that they tend to want to run lately, it seems like people are trying to stretch it further and further. There are different reasons to do that, but I guess one of my questions for you would be, are there specific devices that are more common that you need to go beyond 100 meters, or is it just a plethora of devices?
Yeah, for us, mostly what we're seeing is either wireless access points or cameras, some kind of security device. And depending on how mission critical that is, we can say, go ahead and try it, or I wouldn't recommend it, right? If this is the area where we know there's all kinds of incidents happening and we're trying to monitor it for perhaps forensic evidence down the road, we're not going to suggest that you go outside of your distance limitation because we have no way to really leverage the standards or the expectations within the industry. The other thing that you'll find is that sometimes the manufacturers of those devices aren't going to support the device, right? It's not working. Well, how long is your cable run? Um,
Yeah.
so depending on how critical the application is, they may be willing to risk it or not. But yeah, mostly we are seeing cameras and APs
Right.
as the needed device way out yonder.
Right. And I think one of the missing elements today very often is the support of those device manufacturers, right? You've
Exactly.
got, I think today, if you were to ask Cisco to help you with a non-functioning device that happens to be 120 meters from their switch, they're going to say, you're on your own
Yes.
because they're designing their equipment specifically to IEEE standard, which doesn't specify distances. Well, it doesn't actually IEEE doesn't specify distances at all.
Right.
They specify specific electrical performance, which the TIA, as you know, has built into their standards to accommodate. So it's really TIA standards that justify or legitimize anything that is 100 meters. And if you go beyond that, then you're kind of going outside of the scope of where you really need to be for full support of all your equipment manufacturers.
Yeah, you're exactly right, Todd. And I think that's one of the big reasons why, even though these solutions are out there that work to varied degrees, we're hesitant to recommend them because we will really want to leave clients with a solution that they can rely on and trust is going to work day in, day out. And if it doesn't work for some reason, we usually set them up with designs that will provide a manufacturer's warranty on the cabling side of things. But if it is an overlength cable, even if it's with a manufacturer that's going to warrant it on an overlength channel, if they can't get the device to work and then they don't have a warranty on the device, now we've kind of put them in an untenable situation.
Exactly. Have you included other methods of supporting devices that are beyond 100 meters from a closet that may be supported by warranty?
I know that we have done things, but I don't know that they were actually warranted. I think it was when the clients were willing to risk, it'll work or it won't work. But because we don't have the budget right now, the best thing we can do is try it and see.
Sure. You talk about budget, and you briefly mentioned the installation of another room or at least another cabinet that houses an additional switch,
Yep.
and those kinds of things. And more often than not, that's a cost that is pretty high when you compare that to just running the cable, an extra 10, 20, 30 meters. That extra cost is, let's say, more than they want to spend, with the understanding that there's a certain risk factor that if they can't get the device to work with a standard copper cable beyond 100 meters.
Yeah, that's it. And, a lot of the buildings that we work in, it's remodeled. Some of them are very old buildings, maybe not historic, but old enough that when they were designed, power requirements were very different. So it's this cascading effect of we need to add a cabinet, we need to add a frame room. The first challenge is even finding the space to do that, right? Maybe there's an actual closet in the space that we can kind of tuck something into, maybe there's not. And now we're sticking this box on a wall that is used. And are we sticking it high enough up that it's out of the way, but then we can't service it? Or are we sticking it down low enough that we can service it, but now it's really kind of in the way of the use of the space? So you've got that. You've got this consideration of power and grounding and bonding and all of the things that we should see in this space, whether it's a cabinet or a purpose-built room. Now, in an older building, perhaps your panel won't even support that. I mean, these are just cascading things that I want to add an AP at the edge of my stadium. Sounds like a simple ask when actually there's quite a lot more that could come into play. And that's where we start to see clients risk it initially to see what they can get.
Yeah. I know you have participated in the TIA standards document development for a long time, as have I. And do you think that TIA would ever consider creating a new standard like the 568 standard for copper cabling with a maximum distance that goes over 100 meters?
That is an interesting question. I know that they are interested in exploring it. I don't know whether we'll ever actually see a standard come out of it. And one thing I didn't mention before is that, we have fiber solutions that will go these extended distances, and there are hybrid cables that will carry both, the power and the signal. So it's not that there isn't a solution out there, but a lot of times our clients at least aren't interested in, having to convert that signal. And so this is, I think, the biggest push for the extended copper cabling versus a solution that might already be out there. So with TIA, you've got a lot of folks saying, well, we already have a solution for this. Why are we trying to find a new solution? But we also need to recognize that there is a need and a call for this in the industry. Whether or not we actually get there is a different question. We're working on a white paper to kind of explore the possibilities and see what makes sense. And as a kind of parallel effort, there is a TSB in process. But I'm still really interested to see where we land on this. One of the things I really appreciate about TIA is the actual testing that goes into these documents. This isn't just, hey, we think it'd be great to have a longer channel. Let's just go ahead and write it into the standard. There is a significant amount of work that goes into whether or not we accept this as a standard or how we craft it as a standard before we get this guidance out into the community and into the industry. I'm not sure I fully answered your question there. It was a little bit of a sidestep, but
No, I'm glad you mentioned the TSB because I think for the audience that's not familiar, a TSB is a technical services bulletin. It's sometimes misconstrued as a standard, a compliance standard, but in reality, it is technical guidance, right?
right.
It is not a document that you design to. It is a document that says, if you want to try this, here are the things you need to consider.
Correct.
So a TSB, as you mentioned, we are trying to create this document. And one of the things that you mentioned is TIA does great work in really vetting the technical merits of any document they put out. And there's a lot of testing that goes on. And TIA is made up of many different industry players, and most, if not all, of the manufacturers in our industry participate on these standards committees. So it is a consensus document that will be giving specific guidance on the technical merits of going extended distances. So for me, the TSB document is going to at least inform the end user or the designer on here are the things that you need to be aware of. Here are the things that you need to take into account in the environment and those kinds of things. So yeah, I'm glad you mentioned that. On the flip side, we do have IEEE that develops the actual Ethernet transmission standards.
Mm-hmm.
Do you think they'd ever kind of look at another version of the gigabit Ethernet or fast Ethernet standard that would incorporate longer distances than 100 meters?
I've heard rumors. I am not actively involved in IEEE, but some of our colleagues are. And, I've started to hear rumblings that there might be some interest in picking up some of this. And I think that's really important, especially if TIA is going to consider any kind of a standard around this. I think any group, IEEE, TIA, or others that are doing this in a silo really run the risk of kind of breaking the whole ecosystem of a standard, right? The whole point is so that we can have some assurances that our systems will work. And when we don't have people playing together to make sure that it's going to work end to end, not just the cabling, but the devices that we're attaching to it, we really run the risk of doing a disservice to the industry. And so I am hopeful that we will get lots of people looking at this challenge, lots of people looking at this problem across all of these different organizations to put together a solution that really is viable. So, I mean, they are working on the single pair Ethernet, which they've got a spec to support up to 500 meters. So perhaps we're starting to look that way, and I hope so.
Yeah, you mentioned single pair Ethernet, which is some may not be very familiar with that technology, but it's been around for some years. In fact, I was just talking to some partners in Asia that have some solutions, and they're really seeing in Asia and Europe it be deployed primarily in industrial environments because it's very compatible with some of the older protocols that were for industrial controls like Profinet and
And the
those kinds
backnet
of
and
things.
such.
So
Yeah.
the big question mark is, will it actually start to appear in equipment that is used in commercial buildings for HVAC control or other things like that? So,
I was just going to say, I think you're exactly right. This building controls and industrial applications is exactly where we're hearing most about it. We haven't been deploying it or, designing it in yet. But again, you start to see silos in how some of these systems are designed. And you've got MEP, mechanical, electrical, and plumbing engineers working on certain systems. And then teams like mine that are working specifically on your Ethernet cabling for internet and some of the other applications that we're supporting. So I do think it will be interesting to see where all of that lands and when we start to see it really being considered for more than just the industrial application.
yeah. We mentioned other methods of deploying longer distances from a closet. Uh,
Mhm.
do you ever have a rule of thumb where you recommend the use of optical fiber connections or media converters?
No. I mean, that's the simple answer. It's our clients. We haven't done it since I've been with the company.
Okay, that's
And not to
fair.
say it's wrong, it's just not a methodology that our team or our clients have really embraced. And I think it's the converters, really. They don't like anything that they have to convert. It appears as a point of failure,
Sure.
whether or not it actually is, right?
Yeah. Have you had any clients that you mentioned earlier that you recommend to your clients that if they want to try something that they are prepared maybe for failure, but you're not specifically saying, yes, this is blessed. Do you have any clients that have made their own decision to connect a device further than 100 meters and then experience some problems?
Yeah, it is pretty hit and miss. I have more anecdotal than hard evidence, but I can think of at least one high school where they went out quite a ways beyond 100 meters. And that was for a wireless access point. And it worked, but it would just downshift right to the lower speeds instead of what the device was really capable of. There was another one out camera, I think, out in a pool area. It was nearly 500 feet, I think. That one we did end up having to add a midspan power device to even get it to work. So, yes, we've seen it happen as far as actually installing the stuff, but we've also seen it not be very reliable or, just not really be operating at the capacity we'd like to see for these items.
Yeah. And you mentioned earlier too that if it's a mission critical is involving the security of your site or maybe even access to your site with access control devices, those things can be very, very important. And if you have intermittent problems or another application that I think of is a IP blue emergency phone on a college
Right.
campus,
Yep.
right? You do not want those to have intermittent failures if they're beyond 100 meters. You want them to be completely functional at all times. So,
Yeah, that's exactly it. And I think also we have to think about the environment, right? With TIA, we tend to test and recommend based on a worst case. It may work when you do this inside of a temperature controlled building where we have relatively stable conditions throughout the year. But if you're thinking about running something outside or potentially, a lot of the school districts that we work with, they turn off the building air systems during the summer. And if it gets really, really hot in those buildings and there's no air, you're having some drastic swings in temperatures, and that can definitely affect the performance of your cable.
absolutely. And the other thing that we've been asked quite often is we need to connect this device, and it tends to be in a non-temperature controlled environment, like a parking garage
Hmm.
or a athletic field or outside the building for security cameras where you've got a section of the cable maybe running in a conduit across this top of a building outside, and that those temperature swings can be very significant. And what we're cautioning people is, hey, this could be working great when it's springtime and it's 70 degrees and everything's fine. And then as soon as summer hits, all of a sudden your camera's not working
Right.
because the temperature increase has been, overcome what the capability of the cabling can handle, because temperature increases means that your insertion loss increases and your DC resistance increases, and you're no longer getting enough power to the device.
Yeah, that's exactly it. I think you bring up a great point. Most of these extended reach devices, none of them are in the perfect conditions. That's the whole point, right? It's usually a difficult place to get to, and we're just trying to stretch everything to make it work. And unfortunately, that's going to be likely the worst case scenario for any kind of non-standard application and
Exactly.
installation.
Yeah. Well, Diane, is there any other advice that you'd like to give our listeners on their potential for going beyond 100 meters?
I would just say be cautious. Go in with eyes wide open. There may be good business reasons why you want to go ahead and try it, but you really need to be honest about what you're trying to get out of it, what you're expecting, what kind of support you might need from manufacturers on that end device, and seek out maybe the advice and the guidance of people who are doing this a lot, whether it's the manufacturer of whatever product you're trying to install, or someone like our firm that does this on a day in day out basis. Just make sure that you know what it is you're getting into.
Exactly. Well, thank you so much, Diane. I really appreciate your being with us today.
Hey, not a problem.
Beyond Bandwidth is a podcast series produced by Leviton Network Solutions. For more information on the topics we talked about today, as well as other enterprise or data center network infrastructure content, or to check out all available episodes of Beyond Bandwidth, visit us on the web at leviton.com/beyondbandwidth, or wherever you normally listen to podcasts. If you enjoyed this episode, we'd appreciate you leaving an honest review in your podcast application. Along with word of mouth, leaving a review will help others find our show. I'm Roy Chamberlain, and this was Beyond Bandwidth. Until next time.